What if everything you see around you, the stars, the planets, the galaxies, is not the whole reality, but just a part of it? What if our universe is actually a tiny speck inside a gigantic black hole, and there are other universes inside other black holes too? Hello everyone, welcome to our channel AInything. We came again with another interesting video. Today, we asked AI about what is the possibilities of our universe to be inside of a black hole, and also is it even possible or not, or if possible, then up to which extent, and here is what it said. The idea of our universe to be inside of a black hole is very interesting and speculative one. There is no definitive answer to it, but some physicists have proposed models in which our universe is the interior of a black hole existing inside a larger parent universe or multiverse. Here are some possible aspects of this idea. Number 1, it avoids the singularity problem. The standard Big Bang theory says that the universe started from a point where everything was squished together so much that it had no size and infinite heat. This doesn't make sense mathematically. But if our universe is inside a black hole, then the universe started from a point where everything was squished together a lot, but not infinitely, and then bounced back to form a new universe. This makes more sense mathematically. Number 2, it explains the origin of entropy. Entropy is a measure of how messy or disordered something is. The second law of thermodynamics says that entropy always increases over time in a closed system. But what was the entropy of our universe when it started, and how did it get there? If our universe is inside a black hole, then the entropy of our universe could come from the entropy of the bigger universe outside the black hole, and it could increase as more stuff falls into the black hole from outside. For example, if you have a room that is clean and tidy, and then you throw some garbage into it from outside, the entropy of the room increases. Number 3, it predicts the correct size of our universe. The observable universe is the part of the universe that we can see with our telescopes. It has a radius of about 46 billion light-years, which is roughly equal to the size of a black hole with the same mass as the observable universe. This is not a coincidence, but a requirement for any black hole cosmology model. If our universe was smaller or larger than its black hole size, it would either collapse or expand faster than light. For example, if you have a balloon that is too big or too small for the air inside it, it will either pop or deflate. Number 4, it accounts for the arrow of time. The arrow of time is the direction in which we experience events happening, from past to future. But why does time have an arrow at all? And why does it point in the same direction for everyone? If our universe is inside a black hole, then the arrow of time could be related to the direction of the black hole's growth. As more stuff falls into the black hole, it increases its size and entropy, creating a natural difference between past and future. For example, if you have a cake that is fresh and tasty, and then you leave it out for a while, it will become stale and moldy. You can tell which state came before and which came after by looking at the entropy of the cake. Number 5, it allows for parallel universes. If our universe is inside a black hole, then it is possible that there are other universes inside other black holes, either in the same bigger universe or in different ones. These parallel universes could have different rules and properties, and they could interact with each other through shortcuts or connections called wormholes or quantum entanglement. For example, if you have a book that has different endings depending on which page you turn to, each ending could be a parallel universe. You could also have a bookmark that lets you jump from one ending to another, which could be a wormhole or quantum entanglement. Number 6, it challenges the notion of reality. If our universe is inside a black hole, then what we see as reality could be just an illusion. We could be living in a picture or projection of information that is stored on the edge of the black hole, or we could be simulations in a computer that is powered by the energy of the black hole. This would mean that our perception of space and time is not fundamental, but derived from a more basic layer of reality that we cannot access. For example, if you have a video game that has a virtual world and characters, they could think that their world is real, but they are actually just pixels and code on a screen. They cannot see or interact with the real world outside the game, nor can they understand how the game works or why it exists. Number 7, it implies a cyclic cosmology. If our universe is inside a black hole, then it could have been created by the collapse of a previous universe, and it could eventually collapse to create a new one. This implies that there is no beginning or end to time, but rather an eternal cycle of universes being born and dying. For example, if you have a clock that has a pendulum that swings back and forth, each swing could be a universe. The clock never stops ticking, but the pendulum changes direction every time it reaches the end of its swing. Number 8, it violates causality. If our universe is inside a black hole, then it could be affected by events that happen outside of it, such as other black holes colliding or merging. This could create paradoxes where effects happen before their causes, or where information travels faster than light. For example, if you have a phone that can call someone in the past or the future, you could create a paradox by telling them something that changes what they do, which in turn changes what you tell them. Number 9, it contradicts observations. If our universe is inside a black hole, then it should have some observable consequences that are not consistent with what we see. For example, it should have a negative curvature, meaning that space would bend away from itself rather than towards itself. It should also have a finite age, meaning that we should not see objects that are older than the black hole itself. However, these predictions do not match the current data from cosmological surveys. For example, we see that space has a positive or zero curvature, meaning that it bends towards itself or stays flat. We also see objects that are older than the age of the observable universe, such as the cosmic microwave background radiation. Number 10, it lacks empirical evidence. If our universe is inside a black hole, then it is very difficult to test or prove this idea experimentally. We cannot directly observe what happens beyond the edge of the black hole, nor can we communicate with other universes inside other black holes. We can only rely on theoretical arguments and indirect clues to support or reject this idea. For example, we can use mathematics and logic to explore the implications and consistency of this idea, or we can look for anomalies or patterns in the data that could hint at its validity. In conclusion, the idea that our universe is inside a black hole is an intriguing but speculative possibility that challenges our understanding of reality. It has some advantages and disadvantages over other cosmological models, but it also faces many difficulties and uncertainties. It is not widely accepted by most physicists, but it is not completely ruled out either. It remains an open question that awaits more research and evidence. And with that keeping in mind, if you like the video and want to watch more like this, then like, comment, and share the video, and subscribe the channel and hit the bell icon to never miss any video. See you next time, and have a great day.